We've got load growth for the first time in a decade, more frequent and more extreme weather events. This piece of the equation will be hugely important to keeping the lights on in the future. Wherever that future goes, we're helping to write the story. Virtual power plants in some way, shape, or form are here to stay.
Virtual power plants were always doomed to fall into clean tech's notorious hype cycle. There are plenty of reasons for that, but start with the name. Virtual power plant means everything and nothing all at once. Then there's the origin story, one rooted in the far less sexy and decades-old concept of demand response. Round that out with projections that utilities could save as much as $35 billion in 10 years by just embracing VPPs, and you have the makings of a hype cycle even green hydrogen can't reach. But VPPs are proving to have staying power. Federal and state policies have opened new markets. The tech works, and projects are being deployed at breakneck speed. I'm John Engel, Editor-in-Chief of Renewable Energy World and Power Grid International. This week on Factor This, I'm joined by Michael Smith, CEO of the leading C&I virtual power plant provider, CPower, who breaks down the technology behind VPPs, where the industry stands today, and the critical markets no one is looking at. That's all next on Factor This from Renewable Energy World. Mike Smith, CEO of CPower, thanks so much for joining the podcast. It's great to see you.
Yeah, great to see you too. And thanks for having me on. I'm excited about this.
Yeah, of course. I've been looking forward to this too, because we haven't spent a ton of time talking about virtual power plants on this podcast. One previous episode, so listeners may remember, I think it was episode 52 with Sonnen US CEO Blake Ricketta, talking more about a very specific project that they did with Rocky Mountain Power in Utah, managing a suite of batteries. But this is going to be a much broader conversation about the VPP opportunity and challenges facing that space, especially since I would put virtual power plants somewhat in the hype cycle conversation that we hear in our industry, though we are seeing real projects. There is real momentum here, and I don't want to start off on a negative note. I will let you respond to that, Mike, before we get into your background and really some of this deeper stuff. Frame this conversation for our listeners around virtual power plants. Is it ready to go? Are we still hoping on some dreams, or are you guys cashing in?
Yeah, you bet. So virtual power plants are here. They've been here for a long time, and they're here to stay. I fully appreciate the buzzword stuff that happens in our industry. Having been in the industry for a long time, I've seen a lot of buzzy things come and go. But VPPs, virtual power plants, may be new nomenclature, but it's not new concepts. And what it denotes is the evolution from an old world of demand response, which was very much a blunt instrument of just reducing demand in times of grid stress, to a much more refined and sculpted product that behaves just like a power plant. That's why it's a virtual power plant, but it's a power plant in the same products and reliability and deliverability that any other power plant would provide to the grid.
Yeah, that's excellent. And you'll walk us through a bit of that timeline and evolution from, basic demand response to virtual power plants. But I think what feeds that buzzy nature of this space is that a lot, maybe not a lot, but we have some providers out there who are describing themselves as virtual power plants when it appears to be demand response with a sexier label. Before getting into more of that, let's break down your background a little bit, because you have an interesting perspective here, having worked on the utility side, the developer side, aggregator, software. I'm really interested to see how your path led you here to CPower, which is now, by many accounts, leading the race on this VPP front. So why don't you start there?
Yeah, I appreciate you asking that. It's probably the least interesting thing we'll talk about today, but I'm very fortunate to have, nearing a 30-year history in this industry. I was trained as a lawyer. I practiced trial law for a while. I jumped in almost 30 years ago into the energy industry on the legal side, writing natural gas and power contracts as those markets were opening to retail competition. So I had a front row seat for that. I moved into the regulatory side, and I was able to work in kind of the formation of the MISO market. I worked in front of the FERC for a while. Then I began my journey into the commercial side of the business, leading solar and energy efficiency business. I've done some venture investing kind of on the cutting edge of renewable energy. I knew CPower from my prior work experience in the Constellation Exelon family of companies. And when this opportunity came up, it was something I really jumped on because I realized from my work in the industry that this gap filling nature of this virtual power plant business that is helping us with the energy transition, creating low cost, environmentally friendly ways for grid operators, both utilities and RTOs, to satisfy the increasingly important reliability needs that they're faced with, was a real interesting piece of the industry. CPower is the clear leader, and it was for me an opportunity to continue my leadership roles in this industry, something I really feel very passionately about, being very extremely important, not just to the grid, but to the customers that we serve.
Okay, so let's go through that timeline that we were talking about. Can you walk us through the evolution of this space? Virtual power plants, you mentioned this is kind of decades old concepts that is now going from, hey, turn your demand down to we can inject power into the grid to actually support, resource adequacy and grid services and all these different things. So what are some of those milestone moments that you can share as we've now gotten to this point today?
Yeah, the story is one of technological evolution, both in terms of the actual devices that can be controlled and create value for the grid and how the grid accesses those devices. So in the old days, let's just round it off to 20 years ago when CPower got its start. Markets began to value the ability of a customer to reduce its demand in times of a discrete need on the grid. We called that demand response, and that's still a piece of the virtual power plant paradigm. That was very much a manual process. The grid operator said, hey, I need demand to come down. We would get a call. We would place a call to a customer, and the customer would do something manual at its place of business in order to respond to that what we'll call dispatch, for the lack of other way to describe it. As time progressed, and that was generally, I should say, turning down the lights, euphemistically, reducing the demand of the energy consuming devices in the building premises. Moving forward, more and more devices are capable of responding to that request by the grid operator. So now we have on-site storage in a lot of places, increasing backup generation in a lot of places, better building management systems that can respond to a digital signal in a lot of places. We have computing load that can change. We've gotten better HVAC systems that have variable speed drives and more kind of finesse to them, if you will, more ability to change a load profile of a structure. And this is incredibly important without impacting the customer's unique operational parameters. And you have to have both. You have to have the ability to respond either manually or automatically, but you also have to be able to do so in such a way that the customer can continue its business while responding. The other evolution has been in the grid programs that value these attributes. So you have your normal kind of emergency capacity programs, but now you have these assets being able to participate in the ancillary service markets and participate in the energy markets. And you have better technology in the middle to coordinate all of this. So we can, and VPPs and our VPP providers in our industry can take a digital signal from the RTO, a dispatch signal, pass that automatically through to the customer and get automatic response. Now, that doesn't have to happen that way, but it can happen that way, and it happens more and more that way. That's how you move from kind of a very one-note demand response profile to a much more sophisticated virtual power plant profile.
Define virtual power plant in terms of what it actually is doing today. And I guess that'd be in the context of the work CPower is doing. So we have a lot of terms we're throwing out here: VPP, aggregators. It's my understanding that you're taking a bunch of little stuff relatively, bundling it together and saying, this is an asset that can be valued and participate and support the grid in various different spots. And we will use our software to make sure that it's there when you need it.
That's almost perfect, John. So the way I would rephrase what you said is a virtual power plant is an aggregation of very small load responsive assets that can be aggregated together and dispatched by grid programs that value those assets to create value, not just for the grid operator, but for the customer that provides the asset or the attribute. We think about it very much in terms of assets and attributes. And the key here is a virtual power plant is every bit as firm and deliverable in the attributes it's providing than a traditional central station power plant. The difference is we're doing all of this by reducing the consumption of the collective customers at the point of consumption rather than creating new electrons. And obviously, the result of that is extremely environmentally friendly as well. The most environmentally friendly megawatt hour is the one not used. And that's exactly what we're doing.
And then there's the injection piece. So with on-site generation resources, whether you've got a bunch of solar on top of a warehouse or some backup generators or batteries, when does that come into play in making a virtual power plant not just demand response, but something that goes both ways?
Well, it actually, in very rare circumstances, are we injecting power into the grid for a whole bunch of reasons. Generally, what happens is when we turn on, for instance, backup generation, that backup generation is serving the load on the site and thereby reducing the site's demand on the grid. We don't need to backfill. We don't need to inject on the grid. The grid provider would prefer us not to inject on the grid. This is very much using all of the resources at a particular building in order to moderate the demand of that building represents on the grid. We do that a bunch of different times in order to respond to events.
Okay, excellent. And then the last piece of this foundational chapter of this conversation, help us understand the players and what you do differently, because a lot of people are claiming to do CPPs or VPPs, excuse me, but have different approaches than CPower. You have CPower, Sunruns, Sonova, other aggregators that are, I think, Energy Hub, and another one in the space. How would you differentiate what each of you do, and maybe where is the most common overlap?
Let me start with what we do, and then we'll take it to kind of how it compares to others, because there are others in the space that are comparable to us. One, we're national. We're involved in something like 50 to 55 programs nationwide where we think we can create value for the grid and for the customer. Two, we work directly with the customers who are providing these attributes. So we stand directly between a big box, national big box retailer and the various grid or utility programs where they participate. Three, we are able to what we call stack attributes or stack megawatts. So a single megawatt can be in an emergency capacity program. It can also participate in ancillary services or energy programs as needed by the RTO or the utility. What that does is that we have software called Enterwise that allows us to do that, allows us to optimize the value of the attribute for the grid operator and for the customer, just like a peaking plant. The peaking plant will get paid capacity. It'll get called for ancillaries. It'll get called for energy. We do exactly the same thing. We do that on a nationwide basis. There are others that do that very similarly to us. But then there's also aggregators that will aggregate various types of attributes, various load, but not have the ability for any number of reasons to actually participate directly in the markets. We would partner with somebody like that to take their aggregation and put it in the market. So that's one way a VPP can work. VPPs can also be very localized. It can be just a single utility VPP. We're not doing any of that as well. We have our own kind of national space with 2,500 unique customers, and we are building the capability around that type of attributes. And I would say, finally, the vast majority of our customers are large industrial and commercial customers. We are doing very little with the much smaller customers, but are very interested in that space.
Okay. And that was going to be my next question. So I'm going to put a pin in that one and come back to it in this next conversation about the opportunity here. But you were talking about attributes, and I think that's an interesting component to this, especially for those on the outside looking in. What is an individual attribute for these customers? How do you measure that and quantify the value at any given moment, and then ensure that it's part of that greater bundle that then you use in the market to monetize?
So when we approach, let's just say we approach a new customer, we'll do a study with the customer of what capabilities they have. What kind of HVAC system do they have? What kind of lighting system do they have? What's their ability to control those systems? Do they have on-site storage? Do they have on-site generation? Do they have other industrial load that can be flexed in response to a signal? And we'll come up with the customer and what's the bundle of attributes that particular customer has at that particular site. What do we think their kind of base load demand is, and what do we think they can get to when they're called? That's the capacity that we will then put into the program, whatever program we're talking about for that purposes. We have an engineering team that, when needed, will spend a lot of time with the customer really digging into, what are the attributes that they bring to the table, and what are their operating parameters. And this, I've used that before in this conversation. It's really important to understand what's the customer's tolerance for dispatch. If they are, a hospital, they can't just shut down when the grid needs them to shut down. So you have to be very, very conscious and work very closely with the customers, not just management team, but engineering team, on what are they capable of doing. And, one of the evolutions of VPPs is we can do more with very little impact on the building environment. So you can turn down lights a little, you can turn up or you could turn up the HVAC set point a little bit, have zero impact, but still provide value. And that's some of the benefits of kind of more of the fine tuning that we can do these days.
Back to this broader opportunity. I know Jiggershaw at the loan programs office is very high on virtual power plants. He wants more companies to come to him and the DOE asking for money to scale this. Sonova being one of those companies that has taken that opportunity. I think they got something like $1 billion to help scale their effort at more of the resi level. And a recent Brattle study that made the rounds also found that U.S. utilities could save an estimated $15 to $35 billion in capacity investment over 10 years by really leaning in on virtual power plants and this value of distributed energy resources. Now, there are many who, on the flip side, don't think that virtual power plants are ever going to take a significant slice of the pie and defer those investments to a scale that matters. I know you don't agree with that, but how would you classify the opportunity here, given where we're at in terms of market expansion, adoption, and any of the kind of technological hiccups that could come along the way? How do we make sure that this truly is a fundamental resource within the broader scope of the energy transition?
Yeah, I guess I would respond to that with a rhetorical question. Before the market writ large would invest additional capital for new power plants or new transmission lines, which capital has to come from somewhere. At some point, an energy user is paying for that. Shouldn't we ensure that the system is operating at its optimal capacity, or as optimally as it can, before we make those investments? The only way to ensure that is to know that demand writ large is participating in the market to the fullest extent that it can. Only then can we know that the system itself has squeezed out the optimization, the efficiencies that it needs to. And then we can start to say, okay, now we can start to plan for additional investment. One of the things we're working on in the state level is getting utilities to use load response as part of their planning protocols, to say, okay, what are we doing in load space before we decide to make additional investments in steel, wire, glass, power plants, et cetera. And I just would pick up then on the value of this. Not only, you cited the Brattle report, of course, but even the DOE itself, says, we need another 80 to 160 gigawatts of this stuff by 2030. And if we do, there's $10 of savings just in the next 6 years, 10 billion of savings just in the next 6 years. So I think there's a pretty broad recognition that this is an important piece of the energy transition. It shouldn't go away because it ensures that the grid assets are operating as optimally, as efficiently as they can before we start to make, additional capital investments. This isn't going to take over the world by any stretch, but it has to be a piece of the puzzle going forward, because the virtual power plants, the technology exists. It's happening right now. It's keeping the lights on in events like Storm Elliott 2 years ago in PJM. So it's a hugely valuable asset. It's got to be part of the overall planning picture going forward.
FERC Order 2222. So I know you lived around FERC world for a while in your career. How critical was that ruling from FERC in scaling VPPs? How much did it influence your decision to join CPower? I'm curious about that. And just kind of the quick headline, FERC Order 2222, for those who haven't been beaten over the head with this over the last several years, required our regional grid operators to develop programs and frameworks for aggregated distributed energy resources to participate in wholesale markets. Really, I think the goal to unlock some value for these assets. It's been a bit of a clunky process in rolling that out. I think one of our first ones in New York, which you were participating in at CPower, is finally getting off the ground. But help frame, how important that ruling was from FERC.
With most things from FERC, this is my opinion. First of all, it's very important. 2222 is very important. As with most things from FERC, the kind of overarching regulatory approval of this process is hugely important. Of VPPs is hugely important. The implementation, so FERC got it right for sure. The implementation at the RTO level has, of course, been slow, but it usually is in these types of changes. And we're participating in all the places where we need to participate in this. Well, we're finding a lot of value in participating at the state level and getting state regulators to rethink how they view distributed energy resources. So Missouri now allows distributed energy resources to participate in markets. Michigan allows these resources to participate in markets. I think there's a lot of value to be had there. The 2222 implementation will kind of go under its own steam. Again, very important, but it really doesn't, affect the day-to-day of how CPower does what it does in these markets. Hats off to New York with the DER participation model, something we were, very involved in, helping craft, and we're ready to roll in that. And we'll see more of this as time goes by. FERC sets the tone, but we need to make sure the implementation is right at the RTO level.
I love the creative names for 2222 because we've all had to say it so many times. My favorite one going so far is 2x4. I heard that. I heard that recently, and it's so simple. But there's plenty of them. So feel free to share your favorites. Technologically, so how much do you cross over with the utility or depend on their infrastructure? Both, obviously physical with the T&D side, but the software elements, ADMS, DERMS, controls. Do you sit completely separate of them? Do you have to integrate in some way or another? I'm curious about that, and what, if any, limitations we currently have in controlling and optimizing these assets.
We have very good relationships with our utility partners, and I do mean they're our partners for a whole bunch of different reasons. I'll set aside just our participation in utility demand response programs now, which we do, but I think the question you're asking is much broader than that. We rely on the utilities to get basic usage information, demand information, historical information for our customers as we're getting them prepared to enter a program. That is, like any other utility process, think about retail choice energy. That can be pretty clunky and it can be challenging from utility to utility, but we tend to work through those things. Getting that information more streamlined, more quickly would be helpful to our business and what we represent in the market. On the back end, we use utility generally settlement grade data to settle with our customers. So how did they perform? Getting how they perform comes from the utility meter. There are ways we're working on to get that information sooner than the utility kind of normal settlement cycle. But that information comes from the utility meter. Generally, there's some places we put our own meter in, but most of the time we're getting that information from the utility. But then generally, as utilities have their own programs, some are, bid out programs that we participate in. Some are just the ability to capture customers within a utility jurisdiction for utility programs. We're active in those markets as well. We see it as a very good symbiotic relationship.
So what would you identify as some of these limiting factors? I think you touched on a couple there with, just your access to data and metering telemetry, all that kind of stuff. But where are the pain points for you today, and what are you guys doing to address them?
We're working. So the biggest pain points are the ones I mentioned. And one, getting customer specific information directly from the utility in a streamlined and efficient fashion. Two, just getting usage data after the fact, after participation, in a way that we can, not just settle with our customers, but also demonstrate to the customers how they did on a timely basis. On the first one, particularly the access to data up front, we're working with state regulatory commissions to sensitize them to this issue. It's important to us. We are able to work through it, but it would be better if we were treated, for instance, like a retail energy provider, where the utility is required to provide certain information by a certain time after request. That would be better. And generally, most cases we're not. We're treated differently, and it's harder for us to get that information. It's not like the utilities are violating their tariff anyway. It's just that the tariff doesn't really kind of account for somebody that is a VPP as opposed to a retail energy provider. So again, working with state commissions on those issues, we doing that, across the board where we need to. I think we've been pretty effective in that case. And the state commissioners are really interested in the product that we're providing to the market and learning more about it and learning how, their states can be, more effective at allowing this technology to prevail.
Can you walk us through some of the market maturation and where are some of the most exciting areas right now and some of the markets that you're watching closely? It's kind of a different question. You mentioned the resi element being interesting to you, and maybe we get to that on the back end of your answer. But I'm curious, kind of which trends you're watching most closely right now as it relates to virtual power plants.
So of course, the new New York DER participation program is important to us, and making sure that we help them get it right and we participate as best as we can is high on our list. Two, MISO opened a couple of years ago. It's a burgeoning market. We think there's a lot to go on there, so we're spending a lot of time in that market. And then three, SPP doesn't have a capacity market, but we have customers that have assets in ERCOT and SPP. They'd like to see us in that market more, so we're spending more time kind of evaluating. That's a bilateral market, but what that could look like for us and how we participate, what the value would be for us and our customers in that space. I think those are the big three for me at this point.
So with virtual power plants, we seem, at least we on the outside who are not working on this every day. I brought up FERC Order 2222. We talk about the RTOs, ISOs as driving the bus, which I think you indicated is not the whole story, and that states have a play here, utilities have a play here, and there's more than just what happens at the grid operator level. But I want to talk a little bit more about these non-RTO vertically integrated regions and what opportunities you see there. And I got into that with Blake from Sonnen in talking about what they were doing with Rocky Mountain Power, and he indicated that Duke was coming to their summit to talk about some of these virtual power plant things that they're putting together. And I think Southern Company's looking at this in some way, shape, or form. What is the opportunity there? Because I'm rambling here, but I get really interested in the vertically integrated utility because they're typically cast as the bad guys here, but they also have the ability to move in a way that others don't, in that they can try really big, difficult things, really expensive things at times, nuclear, offshore wind, hydrogen, you name it. Where's the opportunity in those spaces?
I appreciate you asking that question because it's something I think about quite a lot. I think there's enormous opportunity in the traditional kind of more vertically integrated markets. I think the time of the kind of open markets looking down upon the vertically integrated markets is actually, kind of quaint and antiquated at this point. There's room for both in our regulatory construct, and FERC is set up to allow room for both in our regulatory construct. We tried to, over a decade ago, create retail choice across the land, and that didn't happen. And, that's fine. There's a lot of great attributes about the kind of traditional vertically integrated markets. Like you said, they can move fast. They can make, big decisions. These markets are going to need to have load participating in balancing the market, just like any other RTO market. It may look differently, but this, again, back to this concept of, do you really want to invest more dollars when the current infrastructure is suboptimized? The answer's got to be no, because you don't get to good investment decisions. So my view is these markets will be more and more interested in how do we account for load flexibility in our investment decisions. And my instinct is there's a place for a company like CPower, who's been doing this for a long time, to be involved in those conversations. If as simple as sharing best practices, that would be great. But I think there's a place for us to use our technology to help these, our vertically integrated utility brethren get better at what they do.
Well, especially since a lot of those regions are seeing the highest demand for, new data center interconnections and 500 megawatts wanting to come online in 6 to 12 months. And how do we make that happen? That at first it's typically a no, and then how do we get there, and then how much can we shave off of that total? But is that something you're watching really closely too, just in this broader movement that working maybe directly with these data center customers to participate even in like site selection and which region should we be playing in, and how will your software help us be nimble and flexible within the confines of what the utility tells us we can do?
Yeah, I mean, all of that should be on the table for sure. I would add to the panoplies of things these markets are facing. Where are the most storms and most weather events, tending to show up too? The Southeast United States, the Gulf states, Florida, the Mid-Atlantic region. So yes, these regions have a lot of load growth, not just with IT infrastructure, but also and data centers, but also just people growth, right? So, and hot weather is going to affect them as, more than any place else, and more storms. So yes, they have a need for this type of product. And, I think we can be there to help, solve this part of the equation with them.
And what interests you about Resi? Obviously, millions and millions of devices, and being able to aggregate those, there's some obvious advantages there. C&I, you're dealing with a smaller number of individual customers, and maybe that's easier path to scale. But why did the C&I came first? Because of the origin story of demand response, I'm assuming. But what interests you about Resi? What's your plan there?
Yeah, so Resi is a potentially huge market, potentially much larger even than the C&I market. And so we were very interested in trying to figure out how to, grab residential load. And it's going to come in the form of HVAC via connected thermostats and probably like hot water heating. Very, very small increments, but millions and millions of endpoints. The biggest constraint there has been with how to treat the kind of statistical baselining of these customers. You can't show up to PJM with a baseline for each one of a million customers and measure against that. You've got to do some statistical sampling across the portfolio in order to get that to behave right in an efficient way. We're working on that a lot, but I think that's one of the biggest constraints to really cracking that market. We've got a couple partnerships with, owners of residential thermostats who have the ability to aggregate that load and bid that into the market. We're able to do that on an aggregated basis, and we're testing that in some spaces. But really getting that right, I think, would open up that enormous market. And again, the operational thesis is you can move a residential customer's air conditioning set point up a little bit, or delay the heating of their domestic hot water, or if they've got EV charging, like mess with delay the charging of their on-site of their vehicle in order to use that load in virtual power plants. That all technology exists and is available. It's a matter of getting it recognized in the right way by the utility or the RTO.
So the toughest piece then gets back to that attribute conversation that we were having earlier, is like, how do you measure the value of so many different customers in a bundle and in aggregation?
Exactly. That's exactly the challenge. And, we think doing it on a class average, on an aggregate basis, is the right way to do it. But it's a matter of getting that recognized in the tariff and then deployed that way.
And there are some, I mentioned some of the Resi providers already trying to do that in Sunrun and Sonova, and their models are different. Sunrun being, the owner that leases a system to a customer, and they have maybe more control and flexibility around how they monetize that asset in the market then. But do you think anyone has truly cracked that code yet on Resi VPPs?
Absolutely not. No, they haven't. And I think that's really, the challenge and opportunity for the market is to crack that code and get more of these connected devices. And the number of these connected devices is expanding literally every day. Get more of these connected devices into the market.
and I keep seeing I can't even keep up with them, but there seems to be a number of partnerships now between either device manufacturer and, aggregator and then linking to you guys on the VPP front. Will that be accomplished more through those partnerships that get someone to scale quicker? I think I saw something about, Google Nest and OhmConnect and everyone, every time I get one of these press releases, tells me this is now the largest virtual power plant in existence or whatever. So that feeds again to that kind of hype cycle narrative that I imagine makes it more difficult for you in a number of different ways. But is that the path to figuring this out? Is it just, pairing with those, device manufacturers?
Yeah, John, I would say from CPower's standpoint, it is. I don't want to, roll trucks to a customer's house. I don't want to have to keep track of multi-million, Nest thermostats. But if I can partner with somebody who Nest or Resideo or somebody else that can aggregate those devices they already have access to, and then use our capabilities to interface those into the various markets, that's where I want to land. And I think that the world around, so as we found, like just in the solar space, right? Resi's a different cat. And so the world around Resi will probably settle somewhere around that, where you have large companies that have the ability and infrastructure to deal individually with a residential consumer, paired with larger entities that can actually help extract more value from that class of assets.
I can hear the trepidation in your voice talking about Resi, given all the challenges that exist there right now. All right, just as we start to land the plane here, Mike, just what excites you most about what you're working on? When you talk with your teams and you think about this roadmap of where you're going, you've obviously been around, the company CPower has been around this space for a long time, but it does seem like one of the more dynamically moving segments of our industry, and one where the story isn't completely written on which direction it's going to go and who's going to be the one that cashes in.
Yeah, I think that's pretty much what excites me about this. Is it is being written, and we're helping to write the story. There is a long-term place for virtual power plants in these markets. Even when we get to where we think we're going, these markets evolve, all the time. They change almost constantly. There's never a dull moment in the energy space, but virtual power plants in some way, shape, or form are here to stay. The customer load side of the equation is important to balancing our grid in an ever more challenging environment. We've got load growth for the first time in a decade in the United States of America. We've got more and more frequent and more extreme weather events, we've already seen coming to us. This piece of the equation will be hugely important to keeping the lights on in the future, wherever that future goes. And that's what excites me about being part of this industry. I'm excited about being part of CPower, of course, because we've got the most customers, the most gigawatt hours, the gigawatts, excuse me. I mean, the whole piece of the puzzle, being a leader in an evolving piece of the market is extremely exciting.
Mike Smith, CEO of CPower, thanks so much for joining me today.
John, thank you very much for having me. I appreciate it.
Thanks again to Michael Smith for joining the podcast. Factor This is a production of Renewable Energy World and Clarion Energy. Join us every Monday as we break down clean energy's biggest stories with industry leaders who actually moved the needle. And please leave us a rating and review wherever you get your podcasts. Thanks for listening, and we'll see you next time on Factor This from Renewable Energy World.